break so that they can get through this process. And then you'll see in this particular error the IDNF. And IDNF means ID not found. That is the address of your data. That is basically the part that says, hey, I got this LBA block. I have this content over here, and it's at this cylinder and this head. And here it is. If you get that error, it can't find the data. It knows about where it is, but for some reason it can't actually make it any further than that. Then you'll see that the next thing it'll move on to is the address marker not found. In that same 512 byte, if it finds the address and you get that and you don't get the ID not found error, it will continue on and try to get the data from that 512 byte block. So you'll see this error that will come up on the screen, and it'll say AMNF. And that means I know where your data is, but I can't find the data. The address marker for that is not there, and so your 512 bytes that follows, it can't find. And then you'll get your standard stuff, which is now I'm going to try to compare my ECC. And the ECC is the error correction code that's in there in the block that says I read a block, but it's not correct, and now I'm going to flag it as an error. And it will typically try, in each manufacturer's drive, they have a certain number of read-write times that they try to get that data back. And if it fails, say 10 times, then they'll actually say I got an ECC error. If it can correct the error using ECC and that the bytes are not so large that it cannot figure out what to do with it, it will not flag it at all. It will actually get an ECC error, but it will never tell you it got one, and it will move on. So if you get an ECC error, then that was beyond the scope of what it could actually correct and move. Every single hard drive is having bad errors all the time while it's reading and writing, but it's just correcting them on the fly and trying to fix that problem. And then you'll get the UNC, which means it was uncorrectable. So any of the high-end data recovery software, you're going to start seeing this kind of a problem, and you're going to have to start reading these things, and then it will abort. But even the free ones like MHDD do a great job of explaining to you the errors, but you have to know what the errors mean. This is the part where I'm talking about where the signal has to be encoded and decoded. On the actuator arm of the hard drive, there is a preamp. And this preamp goes bad quite often. The problem is that when you start getting the clicking noise, it means that I can't interpret your data because I didn't get any data from the head, but you don't know why it didn't get it. You actually have to kind of break this down piece by piece. And this preamp is one of the big problems. The preamp has two different kinds. One is soldered on, and the other one is glued on. So if you have a piece of plastic and you put a drop of glue on a circuit board and you drop the chip into it, what do you think most of it's going to happen if you get really, really hot? It's going to pop off, or something's going to cause one of the connectors maybe not to connect correctly. So it's really difficult to replace this preamp. This preamp is not something that's, in the small confines that you're dealing with. It will be easier to actually replace the entire actuator arm than it will be this particular drop. So the ones that are soldered on, that are physically there, are going to be much better off than the ones that are glued on. And then the voice coil. I talked about the voice coil quite a bit last year. The big thing with the voice coil is that to fix this particular problem, when I go through the steps, is that you have to be careful not to damage the voice coil because it's held in place by a magnet. And the magnet is very powerful. And you can't just stick a screwdriver in there and pry this thing off because you'll actually damage the voice coil. There is a cheap tool that's actually a magnet. It's a very strong magnet, and you can put it on top of the magnet here and pull it off. And it won't damage the voice coil, it'll just leave it behind. So the cause of the click is going to be one of four things that affects this. One is that your platter could be scratched. So when it got thrown off the stairs, the head hit the platter and dug a big hole in it. So this outside area where the head reads is in the 3.5-inch hard drives. This is where the SA area is. This is where the negative cylinders on your hard drive are. On most laptop drives, it is in the center instead of on the outer rim. So if you have damage on the inside ring on a laptop drive, you're not probably going to be able to read the SA area. And if you have a damage on the outside, you're not going to be able to read it for a 3.5-inch drive. The next thing would be this preamp that I just talked about. And then there's obviously possible failure with the PCB board on the bottom, and that something fried, or you walked across the carpet and touched it with static electricity and it fried a chip on the board, and you'll have to try to find a board to replace it. So let's go through some of the things that you can do. The first thing is swapping a PCB board live. Now, this is a data recovery technique that's probably not well published and that not a lot of people talk about. It probably works 25–30% of the time. But the thing is that if you have a duplicate hard drive that's exactly the same as the hard drive that you have damage on, without opening the hard drive or doing anything, what you can do is plug your hard drive in. You set the timing, say in Windows or using a utility, to spin down and put your drive to sleep, say for 3 minutes, something like that. Windows has that standard, I'm going to try to put my drive to sleep whenever I can. Those are the things that you want to set so that the drive will spin down and go to sleep. So you plug it in, you turn it on, it initializes the good drive, the one that actually works, not the one that's the bad drive. After it initializes and it puts it to sleep, you can actually unscrew the board, and you got to be really, really careful here not to get these screws rolling around on your board. If you take a screw out, it rolls around, you're probably going to get a little bit of a smoke coming from it, but it does happen. And after you take the screws out, you can physically just move the board. It's 4 screws in most boards, and you can just physically pull it up, put it on the other drive, the bad drive, and go ahead and try to do a recovery. Now, here's the thing that will happen. The system will think the drive went to sleep. So the system is going to think it's the other drive. That means the serial number, the sectors, everything is the exact same as the other drive except for the data. Because it didn't do anything with the data, it hasn't read the data yet. But it has initialized the drive. So what will happen is your bad block lists, your bad block table, both of them, the P list and the G list, will be loaded right now. And the SA area itself as a whole, which is what you want. You want your SA area to be loaded because the other drive is bad, and if it had a scratch on it, you may not actually be able to ever read that SA area. So when you move it over to this drive, you can start doing a data recovery. If it ever powers off or anything ever happens while the drive's in use, you've basically got to start the process over again. But if you can get your files back and you can get it to work that one time, you may actually just be able to copy your file off without having to open the drive or do any other special techniques. And like I said, it works a good 25–30% of the time. You've just got to have an exact duplicate drive as close as possible to this. On my website, I have a section under myharddrivedied.com and presentations that has serial numbers in it and how to match serial numbers on drives and what to look for specifically if you're going to try to find a drive to match your drive. I've also got on the DVD, you've got a white paper. It's about 22 pages long, and it describes every technique that I'm talking about here. And I've also published it on my website with these graphics as stills and the animations on your disk as well. So you can try this yourself and go through each step of the way, but you're going to have a duplicate drive to try to repeat that process. And so you're going to have to find one.